I have to tell you, see, I get bad stories. So I got carried away years ago and I have a carport at my house. So that had a little deck out in the middle of it. Okay, so you had a little deck out in the middle of it, and I didn't like the little deck out in the middle because first of all, there was this funny fence and you have hot mop all the way around the outside, so it's like 4 foot quarter. So I got carried away and built this deck out here a little bit more. And the reason, it's got a pretty fancy railing, but the big reason I didn't like the deck was that it's a carport. Right? It's a carport like this. So how do you get anything onto the deck? Well, there's a door in the house that goes out onto the deck. And the door in the house, that means your barbecue and your picnic table and everything else has to go through the house. Right? Which is, shall we say,
not ideal.
Not acceptable, right? It's frowned upon by domestic partners.
Wow.
And I will say frowned upon by me, actually. I don't like dragging my stuff through the house. So, well, what do you do with a deck that doesn't have any way to get to it? Well, you build a bridge. Okay, not exactly decisive. So what do we have? We have a deck, right? And then, okay, over here, by the way, it was 3 years worth of work to get the retaining wall blocks up to where you would have. You had to do that first because they are, after all, are supporting the bridge. So, okay, and then of course I have to go structurally beef up the carport for that. But anyway, I had it wound up with a footbridge. Right? So now you can walk up to the deck. Civilized people, right? And you don't have to go through the house. There's a door back on this little bay out over there. There's a door that sits out over there. Down the driveway. So okay. So anyway, that's where the madness comes from, right? And so I thought, footbridge. So now how did I make my footbridge? Well, I don't have any really good pictures of it. It's probably best back here with the footbridge. It's just steel. Right? And it's steel tubing. Now I use steel tubing because, hey, it's not very long. In some ways it's easier to work with than I-beam, right? It's not quite as efficient, right? Because I-beam is more efficient for beam because the weight is, there's not really any torsion load on it. But hey, it was easy enough to do this. So anyway, I built this beam, this thing, put this and of course then you have to support the flooring material. And so I said, okay, well, we'll just, in this particular case, it's those 12-inch, 2 foot by 2 foot concrete paving stones. So that, so the maintenance is non-existent, right? Are they gonna rot? No, not gonna do anything. So anyway, I did this, and this led to the dreaded bridge design project. So I thought, hey, it'd be fun to have my FEA students who need a design project, it'd be fun to have them design a footbridge. So I went out and explored the criteria for footbridges. And design criteria for it. So here's our design criteria. Footbridge, our bridge is 36 feet long and 6 feet wide. It's a nice, big, fat footbridge, right? You don't want them any wider than 6 feet because people drive cars across them. And this at 6 foot wide, the only one to get his car across is Taki.
Yep.
And she'd do it.
I would.
So, okay, so, and Okay, it's, so we're gonna build a footbridge, it's welded together. You're gonna weld the footbridge together, they're gonna put it on the truck, drag it out there, take a crane, drop it in spot, okay? That's how they like to install them these days. Okay. Hopefully they get the boom truck there and just drop it off. Okay, 36 inches, 36 feet long, 6 feet wide, and it has two criteria. You need a point load of 1,200 pounds anywhere on the bridge. Okay? And then a distributed load of 50 pounds per square foot. Okay? The 50 pounds per square foot, let's just think a little about where those come from. The 50 pounds per square foot assumes that each individual when they're standing up is gonna take a 2 foot by 2 foot square. That's sort of personal space, right? Minimum personal space. You know, 2 foot wide, that's 200 pounds. Probably not bad. Hopefully, most of you are under that. Some of us like me are not, but we won't talk about that. So we won't go that one. Okay, so that's the sort of average weight in there. What's this 1,200 pounds? Point load. Well, footbridges, people aren't the only things with feet. We have animals.
1,200 pounds, not at all.
Okay. And so animals are
Small.
Small.
small animals, okay. No, we're having 1,200 pound animals. Cattle, horses,
Yeah.
right? Usually on a footbridge, depending on where it is, it'd mostly be horses. Cows, amazingly enough, are smart enough where they'll go around. And if you have a mule, it's usually smart enough to stay the deck, it's off the footbridge. But horses are not the world's smartest critters. He's sort of bred most of the brains out of them, so. I had my horses in my younger days. That was yes. Don't let me go there. So.
And now you have mules, is that what you're saying?
No, now I have. I spent the
Ashes.
last 40 years removing all the fences from my property that would constrain large four-legged animals. So because been there, done that. Don't want to do it again. So
Good.
that's the. Other people can have fun with horses. I'm not going to. My sister and my mother and all are still very much in love with that, so I have to avoid it. Okay, so, but basically, if you count the loads, the other constraints, the deck weight is included in the distributed load. Okay, the weight of the deck is included, but in order to carry the load of the decking, you can't span any more than 18 inches. The decking cannot span any more than 18 inches. So you have to have some structure there that's going to at least carry the load of the decking. I don't care which way you run the decking. If you want to assume it's planks, that's a fine thing. It usually is planks. I don't care which way you run it. Whether you run it lengthwise or horizontal, it's oftentimes run either way. Either way works. Okay? Okay? It's probably more traditional to run it crosswise, but people run it the other way, and that's certain. There's nothing wrong with it. Okay? So you don't need to model the deck or the railing. So trying to make it easy. The only thing you need to model is structure. Structure. Okay? Structure, but your design needs to be able to think about bolting on the railing, because somehow you actually have to attach the rail. Okay? You actually have to attach the rail somewhere along the line. Okay? So we designed the cast safety factor for yielding of 9/5. Manufacturing cost of the bridge should be minimized. Okay. Which means, when I say the manufacturing cost of the bridge should be minimized, what does that mean?
Don't use a lot of material.
Yes.
Keep it simple, stupid. Steel.
Right?
Keep it steel, stupid.
Keep it simple. Okay? Do I expect big, elaborate trusses?
Platinum, right?
Platinum level.
That's right. You're going to be one of those, aren't you? Okay.
Titanium and Inconel.
Okay, yes. Yes.
Maybe I don't want you to help me with
One
the
of,
number
one of those. Okay. That's okay.
I know better.
I'll give up using the roller point and go to the big felt tips.
Oh.
Okay. Okay.
Just for money.
Those big red felt tips, they're easier that way, I don't have to. Okay, so, right, okay, so basically, a footbridge, 36 feet. Well, you can buy steel sections in up to 40-foot length. They're readily available up to 40-foot length. So it's not a problem of making it out of one steel beam. Would I encourage you to do such thing, is make it out of things that are 36 feet long?
Mm-hmm.
Yes. I would encourage you to do such things. Okay? So, because that would be simple. Okay? Oops. Wrong. Doesn't work when I'm seeing, trying to treat it like it's a PowerPoint and it's a Word document. Okay, so you need to give me a short written description of the problem, an FEA analysis of the design with your loads and your boundary conditions. Where do you put the worst case load? If you got a point load on there, where are you gonna put it? Right, where it's all worst case, right? We need stress plots for them. And if you have any nodal stresses that are over the design criteria, any stresses that exceed the 9/5, need a little explanation as to why. It may be that they're a boundary condition and you don't believe them. I'm okay with that. But being a drawing, not a complete, you don't have to do a drawing package, but at least enough of a drawing to sort of lay it out and have some hope that and a bill of materials. Okay.
There's another project too.
3 weeks.
Is this the problem?
The final is
This is due in 3 weeks?
Yep.
This is the final.
This is the
what? Wait, what is the
No.
final due?
I'm so confused.
So when do we get the final?
The final is due,
We don't know final, this is final.
yes, no, this is not the final.
Trying to
Yes,
get
nice
that
try,
done.
but it's not
I
the
know.
final. Okay,
See?
so, yes,
And then final exam project.
yes, so let's see, the calendar, find the
We're
calendar.
gonna have two
here.
projects at the same time?
No,
Yeah.
you'll get done with them, right?
Work
1, 2,
together.
3. So, I'll probably give you the final on the 6th.
On the 6th?
On the 6th.
Get it
June
now.
6th, June?
And
Do
we'll
it
do
now.
the
June 6th?
6th,
Mhm.
do the 15th.
So this is due when?
We get three
Due on
weeks
the
on this
6th.
one.
On the 6th.
This is due on the 6th?
And I may give it to you, I may give the final one to you on the 30th if I get that. Then you'd have 2 weeks. So I would not hesitate with this one.
Yes.
More work.
Oh.
That's what I get for giving you easy projects. Easy, I should have given this to you last week.
That would've been nice.
I don't know about that, that's not me.